Good afternoon, class. We are looking at exam 2 review, chapter 3, differentiation rules. Exam 2 covers from 3.1 to 3.8, and this part covers 3.7, rates of change in the natural and social sciences, 3.8, exponential growth and decay. So first, let me remind you of what we have done, things like differentiation involving logs. So how do we differentiate this? The best course of action is to decompose the log first. We use the product rule. This will be ln of 3 plus ln of x plus ln of x plus 4 to the power of 5, which is 5 ln of x plus 4. My assumption is that we have no problem decomposing a log. This makes it easier to differentiate. So ln 3 is a number. The answer is 0. ln x is 1 over x. Plus 5. Now, ln of x plus 4, flip it over. 1 over x plus 4. 1 over x plus 4. And then by the chain rule, I need the derivative of the inside, the argument of x plus 4, which happened to be 1. So what do I have here? I have 1 over x plus 5 over x plus 4. This was the only calculus step. Now, over here, we have a common denominator of x times x plus 4. So this is 1 times x plus 4 plus 5 times x. And so we have x and 5x, 6x plus 4. That is the numerator. We are done. So it's pretty straightforward. And again, I wanted you to be exposed to what we have done already, which is differentiation, and especially dealing with logs. And the way we deal with them, it's very simple. We make sure that decomposing first, it's a lot easier that way. And now 3.7, rates of change, reminding everyone that when we have two pairs, we can calculate rise over run, delta y over delta x, in various formats. For example, f of x up 2 minus f of x up 1 over x up 2 minus x up 1. And that is the good old slope, known as the average rate of change of y or f of x with respect to x, in this case over the interval of x up 1 to x up 2, and can be interpreted as the slope of the secant line, the blue line, PQ. We recognize the following limit as being the derivative of f prime of x sub 1. Various ways of defining the derivative at a specific point. For example, we've seen these two, and I remind you, this is known as the slope of a tangent line. M or f prime of a is the limit of f of x minus f of a over x minus a as x approaches a, or limit of f of a plus h minus f of a over h as h approaches 0. They mean the same thing. The average rate of change is the slope of the PQ, that means the secant line. The instantaneous rate of change is the m of the tangent line, the red line, or f prime of a. And so the derivative f prime of a is the instantaneous rate of change of y or equals f of x, y equals f of x with respect to x when x equals a. Now with this question, find each of the following. We're going to find the profit when cost and revenue functions are given. And I hope you remember, profit by definition is revenue minus cost. So subtract the first from the second line. So we keep this and we distribute the negative for the parentheses. We get minus 62x squared minus 27,500. And so these two are like terms. We get x cubed. These two will give us negative 74x squared. This remains as 4dx. These two numbers, positive 10, negative 27,500, they give us negative 27,490. So that's pretty straightforward. So the next one is asking for the total cost, revenue, and profit when the production and sale of 50 units of the product is done. So replace the X with 50 in each case. For example, for the cost function, 60 to 50 square times 50 square plus 27,500. You plug in, you calculate, you get 182,500. This is elementary algebra, everybody. I just want to make sure that we understand that. For the revenue, 50 cubed minus 1250 squared plus 40 times 50 plus 10. And that gives us $97,010. For the profit function, we have two choices. One, put it in here, 50 cubed minus 74 times 50 squared plus 40 times 50 minus 27,490, and you get minus $85,490. So of course, what does negative mean? There's a loss. Or we can say P of 50 is R of 50 minus C of 50. And since we have those two numbers, subtract this number from this number, and that gives you the same answer. Okay? So you don't have to take the long way. You can take the easy way. We continue. We have the cost function, the revenue function, the profit function, and we are asked to find the marginal cost, revenue, and profit when 50 units are produced and sold. I want to mention the word marginal in business means take the derivative. And then we are going to see the importance of that, the meaning of that. But first and foremost, marginal means a differentiation. So in this case, if you want the cost, you want C prime of X, which is 62 times 2, 124X. So you plug in 50. C prime of 50 is 124 times 50. And it gives you $6,200. Then R prime of X, 3X squared minus 24X plus 40. For 50 units, we want R prime of 50, meaning 3 times 50 squared minus 24 times 50 plus 40. And we do the math, $6,340. The last thing is P, so we go with P prime of X, which is 3X squared minus 74 times 2 minus 148X plus 40. And evaluated at 50, you get P prime of 50. 3 times 50 squared minus 148 times 50 plus 40. You do the math, you get 140. And again, you can say P prime of 50 is R prime of 50 minus C prime of 50. In other words, if you subtract this from this, you get the same answer, 140. Now, here's the interesting meaning of the marginal cost or revenue or profit. It represents the cost or revenue or profit for the next unit. In other words, when 50 units have been made, C prime of 50 represents the approximate cost of the 51st unit, the next unit, will be about what we got here, 6,200. Now, what is the exact amount? So this is an approximation. This is the approximation. What is the exact amount? You go to the cost function, you plug in 51, okay, minus 50, that would be the cost for the 51st unit. So C of 51 minus C of 50. So let's do that, which means 62 times 51 squared plus this number minus 62 times 50 squared plus this number. You get 6,262. So take a look. These two numbers are the same. No, we didn't say it's the cost. We say it's an approximate cost. But notice they're fairly close. The difference is normally this is a lot easier to calculate. Same thing for the other two. R prime of 50 is the approximate revenue from the sale of the 51st unit. It's about 6,340. Again, exactly like that? No. If you want R of 51st unit, that would be R of 51 minus R of 50. For an approximate profit on the 51st unit of P prime of 50, which is $140. So marginal cost, when it's evaluated at some number, it represents then the approximate cost for the next unit. And the same thing happens for the revenue and profit. The distance in meters of an object from a starting point is given by S of t equals 2t squared minus 5t plus 40, where t is time in seconds. What is the velocity of the object from 2 to 4 seconds? Class, this is elementary algebra. This is basic velocity, which is total distance over total time. The average velocity is S of 4 minus S of 2 in this case, divided by 4 minus 2. The formula is S of t sub 2 minus S of t sub 1. What is this? The exact distance it's going to be covered over the course of 2 to 4 seconds. What is this? The time, 4 minus 2, 2 seconds. So you plug in. We're going to plug in 4, 2 times 4 squared minus 5 times 4 plus 40. Then we plug in 2, 2 times 2 squared minus 5 times 2 plus 40. The denominator is obviously is 2. 16. This is 32 minus 20 makes it 12 plus 40 makes it 52. 2 squared, 4 times 2, 8 minus 10, negative 2 plus 40 is 38. So we get 52 minus 38, which is 14, divided by 2, becomes 7 meters per second. And the units of the numerator over the units of the denominator. What is the instantaneous velocity and acceleration of the object? What is the velocity and acceleration of the object after 6 seconds? Velocity simply means, instantaneous velocity means differentiate. So we're going to differentiate and we get 4t minus 5. So V instantaneous is S prime 4t minus 5. and you replace the t with 6 seconds because they said so. 4 times 6, 24, minus 5, 19 meters per second. Remember, again, I want to make sure you understand that we have here ds dt units of s, the position or distance function over the units of time. That's why you get meters per second. Now, the next one is acceleration. As you may recall from physics, acceleration is the second derivative of the position function. So a of t is v prime or s double prime. That means differentiate again. When we differentiate again, of course, we get 4. 4 happened to be a constant, which means regardless of the time, 6 seconds, 5 seconds, 2 seconds, this will remain as 4 because it's independent of t. If it involves t, you have to plug in 6. Meters per square second. Why is that? I want to make sure we understand the units. A of t is dv dt. And so the units of meters per second, it's meters per square second. When does the object reach a velocity of 31? So the velocity of 31, set them equal. Move the negative 5, make it positive. You get 36 divided by 4. It takes 9 seconds. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. Include proper units. You should always include units in the case of applications. How tall is the sunflower 8 weeks after planting? It simply means plug in 8. That's all there is to it. So this is elementary algebra. 6 times 8 minus 1/4, 8 times 8 squared. So this is 48. This is 64. So 1/4 of that is 16, and you get 32 inches. That would be the height 8 weeks after planting. Find the average rate of growth from the end of week 6 to the end of week 12. It's the good old average. That means delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. And in this case becomes f of 12 minus f of 6 over 12 minus 6. So the denominator is obviously 6. The numerator, you plug in 12, 6 times 12, and minus 1/4 times 12 squared, and then you plug in 6, 6 times 6 minus 1/4, 6 squared. And so 6 times 12 is 72. 12 squared is 144, and 1/4 of it is 36, so 72 minus 36. 6 times 6 is 36. 6 squared is also 36, 1/4 of it is 9, so 36 minus 9. And if I distribute the negative, everybody, if I distribute the negative, I get minus 36 plus 9, and I get 9 over 6, or 3/2 of an inch per week. Units of the numerator over the units of denominator, okay? Units of the change in height over the units of change in time. Find the instantaneous rate of growth 10 weeks after planting. That means differentiate. In general, 1 point in time is differentiation. So f prime of x is 6 minus 1/4 times 2 is half of x. So that's f prime of x. And now after 10 weeks, replace it with 10. Half of 10 is 5. 6 minus that is 1 inch per week. What does it mean? On week 10 or after week 10, the sunflower is growing at a rate of 1 inch per week. Section 3.8, exponential growth and decay. A quantity Q or Q of t or y of t is said to have an exponential growth or decay model if it increases or decreases at a rate that is proportional to the amount of the quantity present. So dy dt is k times y, then is c e to the power of kt. It's an exponential format. Now, if you set t equal to 0, you get the value of c. It's called c or y of 0 or y sub 0. In other words, this we could even write y sub 0. Now, all of this mean the same thing. Various formats depending upon the text. For example, a equals p e to the power of rt, y equals y sub 0 e to the power of rt, and the rest of them. This especially is used for continuous compounding, as you recall. So they all mean the same thing. Okay. Now, C, if we go with that, is the initial value. K, if we go with that, or R, if we go with that, is called the constant of proportionality, relative growth rate. dp dt or dy dt. See, over here we said dy dt is ky. Over here we would say dp dt is kp. It's the same concept, known as, in other words, if you differentiate the derivative, which is k times p, is the rate of growth. But this is relative growth rate. Don't mix them up. So the k or r, if you come up with the terminology, relative growth refers to the value of k or r. The number sitting next to t in the exponent. Whereas its derivative, dp dt or dy dt, is the rate of growth. Or they might say growth rate. Don't mix it up with the relative growth rate. That's the idea. All right. Equation 1 is sometimes called the law of natural growth if k is positive, or the law of natural decay if k is negative. It is called a differential equation because it involves an unknown function y and its derivative dy dt. That's why it's called the differential equation. Now, so dy dt is ky or negative ky. This would be exponential growth. This would be exponential decay. And of course, I want to show you, differentiate what happens. By the way, we want to differentiate this to show that it becomes that. I hope you realize if you want to differentiate this, the derivative c remains e to the power of kt. Exponential is always itself times k, right? So the derivative would be c times e to the power of kt and times k. And what is this part? Isn't the same as y? So it's k times y. We proved that dy dt is y times k or k times y. So if dy dt is ky, y must be in the form of c e to the power of kt. What you're looking at is the Newton's law of cooling, where capital T represents the temperature, lowercase t represents the time. And this derivative is k times t minus t sub s. What happens is that the Newton's law of cooling says if you bring something, for example, a beverage to a room, it ultimately gets the temperature room. If it's hot, goes down to the temperature room, and if it's cold, goes up to the temperature room. And this is the formula. I want to discuss that with more details as we go through that in a few minutes. For now, this is the general form. Let's look at something you all know, the exponential growth and decay, and we look at some examples of that. A population of bacteria grows from 1,000 to 4,000 in 3 hours. Assume exponential growth. That means assume this. Find the population in 6 hours. So we're going to go through this concept, and there are various methods of approaching it. So anytime you have an application problem, write the given. The given is that we're going to use this formula. The initial value is 1,000, and 3 hours later, that means y of 3 is 4,000. So this is given. So the process is to replace the c with 1,000 and find k. In general, we call it y of t, and then we plug in 6 to get y of 6. So this is the process. I'm explaining what we are going to do. We're going to find k, so we have the formula, y of t. And then we plug in 6. How do we do that? First and foremost, we said c is 1,000, so replace it. Then we said y of 3 is 4,000. This is given, right? So if I replace the t with 3, I should get y of t equals 4,000. Let's do that. So y of 3 is 4,000. That means 1,000 times e to the power of k times 3. So clearly, I can drop the 1,000 and change this to 4. In other words, divide both sides by 4. I get 4 equals e to the power of 3k. Now, ln of e to the power of x is x, so we're going to take the natural log of both sides or just rewrite it. Because the base on the right side is e, we go with natural log. And so ln 4 is 3k, divide by 3. So k is precisely, this is an exact answer, everybody. Roughly 0.4621. So we have the formula for y of t. Now, if we plug in number 6, put it into a calculator, we get to the answer. And notice, we get a number very close to 16,000. In fact, population, so you have to round it to the nearest whole number. I want to add a couple more things. Number one, it is possible to rewrite this in the following manner, okay? That we went from 1,000 to 4,000 in 3 hours, right? So every 3 hours, it seems to be getting 4 times. So now, if it's 4 times, then in 6 hours is another 4 times. So 4 times 4 is 16,000. That's how we get. So that's one, again, easy way to do it, but we wanted to do it with the details, with justification, okay? Now, the next one is to write this with an exact answer. So as we go back to the equation here, y of t is 1,000 e to the power of kt. Instead of k being 0.4621, let's go with ln 4 over 3. Exact answer. And I'm going to separate this into ln 4 times 1/3 t, or t thirds. And the reason I do that, because e to the power of ln 4 must be 4. ln of e to the power of x is x, e to the power of ln x is x. So this part, we should know it's 4, so we can write 1,000 times 4 to the power of t thirds. Just in case, if you plug in 6, you get 6 thirds, which is 2. 4 squared is 16, times 1,000 becomes 16,000. So that's pretty straightforward, everybody. Now, when will the population reach 30,000? Set this equal to 30,000. This formula in this format or in this format, we set it equal to this number. So y of t equals a question mark equals 30k. That's the idea. So one of those formulas, as it was mentioned, is equal to 30,000. We can drop 1,000 and drop 3 zeros. Again, let's take a natural log of both sides because the right side has the base e. So the right side becomes just the exponent, 0.4621t, and t, therefore, is the left side, ln 30 divided by 0.4621. And if you put it into a calculator with a bunch of decimals, you get t equals 7.3603, and of course, you put as many decimals as they ask you. Exponential decay model. Physicists express the rate of decay in terms of half-life, the time required for half of any given quantity to decay. Class, reminding you, if y equals c e to the power of kt, half-life results in h being minus ln2 over k is minus ln2 over h, depending upon which one is missing. Y equals c e to the power of minus kt, half-life is h equals ln2 over k. In other words, sometimes we just use the positive for both of them, but when you work it out, the coefficient of t becomes negative. And because it's the amount of material, we may use m of t equals m sub 0 e to the power of kt. The point being is really ultimately the same formula. So a sample contains 1 gram of radium. How much radium will remain after 1,000 years if we know the half-life is 1620, 1,620 years? So what we know is use y equals c e to the power of kt or m of t equals m sub 0 e to the power of kt. And initially y of 0 or c equals 1 with the half-life of 1,620. We want y of 1,000. In other words, we want to explain this symbolically, what we are going to do. Now, what I want to do, I want to show you this concept of a half-life. If we choose to go with y equals c e to the power of kt, we start with the positive. That's what we mentioned here. Let's see what happens. First, it is important if you want to calculate the formula for the half-life in general, it's given here. I want to show you how we arrive at it. It doesn't matter what you start with. The amount of initial value is not important. Here's the reason. Half-life, that means y becomes half of c. So the c from both sides cancel out. So the left side is only 1/2. You take the natural log of both sides, and you get ln1 minus ln2, and the right side is kt. ln1, as you know, it's 0. So if you want k, it's ln minus ln2 over t. If you want t, it's minus ln2 over k. And again, take a look. If we choose y equals c to the power of kt, we get minus ln2 over t. Okay, everybody? That would be k, which makes it negative. If you work on this one, it becomes positive, ln2 over k, okay? Because you are having a negative sign here. And you can try it on your own. So if that's the case, for us here, we have the time, so we want the k. Minus ln2 over 1620. And you go with a lot of decimals. So y of t is c, which is 1, e to the power of k, which is this number, times t. This one I didn't write in front of it. Now, how much will remain after 1,000 years? Replace the t with 1,000. You multiply this by 1,000, so the 3 zeros go away after the decimal, and then you raise e to the power of negative 0.4279, you get 0.652 grams. So about 65% remains. That's the bottom line after 1,000 years. The growth in world population in millions is estimated by the formula P of t equals 8,200 e to the power of 0.011 t, where t is the number of years since 2025. Find the instantaneous rate of change for the year 2050, include units, always include units. Well, instantaneous rate of change, that means differentiate. So we are going to differentiate. We want to find p prime of t. We start with 8,200 that is there. We differentiate this by writing it itself because it's an exponential form. The derivative of e to any power is itself. And then e to the power of kx, we need the k, so we need the coefficient of t here. So that's p prime of t. We're going to multiply this number by this number. We put it in front. And so this is p prime of t. And we want to find this instantaneous rate of change for which year? 2050. So we need to put the t as the difference between the two, which is 25. Put it into a calculator. It results in 118. And make sure you put a lot of decimals, 0.7511. And what does that mean? I want to make sure we understand p prime means dp dt. That means change in population over change in time. This represents change in population in millions, so millions of people per year. Now, so 1 million has 6 zeros, so we're going to put 1, 2, 3, 4, and add 2 zeros. And write in 2050, the world population will be increasing at a rate of 118,751,100 people per year. Notice we moved the decimal. In other words, multiplied by 10 to the power of 6. That's the meaning of it. Now, a couple of things I want to add here, everybody. Remember y equals c to the power of kt. That means dy dt is ky. Rate of growth, okay, or growth rate is dp dt, which is k times p. Now notice, in this case, what is k? K is the coefficient of t, 0.011. Therefore, p prime of 25 is k times p of 25. Why 25? Because of the difference in number of years. So 0.011, that's k. P of 25, just plug in 25 here. In other words, the population is 8,200 e to the power 0.011 times 25, right? Put it into a calculator, you get exactly what you have. This is another way of approaching it that has been discussed, okay? And now Newton's law of cooling. Again, reminding you of what we have done. Now, Newton's law of cooling states that the rate of cooling of an object is proportional to the temperature difference between the object and its surrounding, provided that this difference is not too large. This law also applies to warming. In other words, As I mentioned, if you bring a beverage to the room and it's a hot cup of coffee, it's going to cool down and it depends on the difference in temperature. Or you might bring a cold soda, eventually it gets warmer and it takes the temperature of the room. Please understand it might take some time depending on a lot of factors, but eventually will have the same um, you know temperature as the room temperature. All right. If we let capital T of t, again, capital T represents the temperature, be the temperature of the object at time t, and T sub S be the temperature of the surroundings, then we can formulate Newton's law of cooling as differential equation dt T dt, d capital T per d lowercase t is K capital T minus T sub S, where T sub S, as was mentioned, is the surrounding temperature and K is the constant. So we write dt dt is kt minus T sub S. To make it a tad easier, let's say this is represented by some function, for example, y or y of t. Therefore, dt is ky. Again, it's y of t. It's a shorthand notation. So if that is the case, if y is t minus T sub s, okay, if y is t minus T sub s, please understand this capital T means t as a function of t. This T sub s is a number. Let's differentiate. If you differentiate with respect to time, this becomes y prime, this becomes t prime, this becomes 0 because it's a number, everybody. T sub s is the surrounding temperature, is some number. Therefore, y prime or dy dt, t prime or dt dt are the same. So if dt dt is ky, so is dy dt. So according to this, dy dt and dt dt, they are both ky. And y, therefore, follows the formula here, becomes this one, y of 0 or y sub 0 makes no difference. Y of t is y sub 0, e to the power of kt. And look at this formula. Y of t is t of t minus t sub s. So this formula says it's also equal to y sub 0 e to the power of kt, right? These two, understood? And so if that is the case, I can move this to the right and make it negative becomes positive and say capital T of t is y sub 0 e to the power of kt plus t sub s. And if you plug in 0, t of 0 becomes y sub 0 e to the power of 0 plus t sub s. Please understand this e to the power of 0 is 1. So this is y sub 0 plus t sub s. Let me just make sure we understand what happens here. So e to the power of 0 is 1. So t of 0 is y of 0 plus t sub s. That's what we are saying. Therefore, y sub 0, move the t sub s, becomes t sub 0 minus t sub s. It's very straightforward. Let me erase my work. And so, the Newton's law of cooling tells us T of t is y sub 0 e to the power of kt plus T sub s, where y sub 0 is the difference between the T sub 0 and T sub s, the initial value and the surrounding value. That's the meaning of it. A 180-degree turkey is removed from the oven and placed in a 74-degree room. After 15 minutes, it has cooled down to 136 degrees Fahrenheit, find the general solution to 4T. By the way, normally class, we want to find the temperature, let's say in 20 minutes, 30 minutes, 60 minutes. But I highly recommend you find this because they may not ask you for this. I like to do that. And to do that, I want to write the given as I read. It's 180 degrees to begin with. That's T sub 0. And bring it to the room. That means the surrounding temperature is this. And after 15 minutes, T of 15 is this. So you write the following. Given T sub 0 is 180 degrees Fahrenheit. T sub S is 74 degrees Fahrenheit. And after 15 minutes, T of 15 is 136 degrees Fahrenheit. That is the given. So we want to find the general solution. We are going to write this formula. And we remember y sub 0 is the difference between the two, T sub 0 minus T sub S. We're going to write this as 180 minus 74, which results in 106. So the formula becomes T of T equals 106 e to the power of kt plus 74. We have everything except K, because T of 15 is 136. We can find the value of K. So if I replace the T with 15, then this one I have to replace it with 136. So again, T of 15 is 106. E to the power of K times 15 plus 74 is 136. We are solving for K. We are going to subtract 74 from both sides. Resulting in 62 on the right. We're going to get rid of 106. That means we're going to divide by it. Now, notice I don't want to simplify this. Of course, the fraction can be simplified. I do it on purpose because I want you to see where the numbers are coming from. Because this one has base E, we're going to take a natural log, which leaves us with 15K on the left. And K becomes the right side divided by 15 precisely. So ln of 62 over 106 over 15. Again, we left all the numbers so you know where they come from. And now if you put it into a calculator with a bunch of decimals, you get almost negative 0.035754. And so with this formula, we have everything. Now we also have the K, and we say T of T is 106 e to the power of negative 0.035754 T plus 74. Now, and that's perfect. Now, if we want to be, we want to come up with the exact answer differently, we can do the following. So when we are here, we're going to simplify this. Take a look at this one. We're going to simplify this into 31 over 53. Then we solve for e to the power of k. Notice this is e to the power of 15k, which means it's the same as saying it's e to the power of k to the power of 15. That means the same thing, right? So if you take the 15th root of both sides, that means raise them to the power of 1 over 15, you get e to the power of k on the left. In other words, this is e to the power of k to the power of 15. So to the power of 1 over 15 gives you e to the power of k, this one to the power of 1 over 15. And so because over here is e to the power of kt, everybody, we want e to the power of kt. So e to the power of k is this, e to the power of kt, raise this to the power of t, which makes it 1 over f. Let me show. This is just basic, just to the power of t, right? That means multiply these two. So e to the power of kt can be replaced by 31 over 53 to the power of t over 15. And please understand these two are identical. This one with the number, where is that? This one. But this is a little bit more precise. Just remember we use the approximation. Anyways, either way. Now the next part is asking for what is the Turkish temperature after 60 minutes. So you replace the T here with 60 or here with 60. It's a tad easier to do it here because 60 is divisible by 15. As you know, it's 4. So you raise this to the power of 4 and then times 106 plus 74. It gives you an exact answer. And you go with a bunch of decimals. Because you have to stop, then it's an approximation. 86.4065 degrees. How long does it take? How long does it take for the turkey to cool to 110? Just put it equal to 110. Which one doesn't matter? This one or this one. Set equal to 110. To do so, we are going to move the 74. And subtract it from 110 to get 36. We're going to divide both sides by 106. Because the left side has e, we take a natural log of both sides. And the left side becomes just its exponent. ln of e to any power is that power, so we get this one. So what is t? The right side, ln of 36 over 106, divided by negative 0.035754. Putting it into a calculator will give us 30.2, about 30 minutes. It depends on how they want you to answer it. They normally ask you for how many decimals, okay? And so it takes 30.2, about 30 minutes, again, depending upon how they want you to answer. Here's the last question. Put on your detective caps. A dead body was found at 1:30 a.m. when the temperature was 55 degrees Fahrenheit and the body temperature was 87 degrees Fahrenheit. Normal body temperature, we know it to be 98.6 degrees Fahrenheit. Roughly, is has been, worked on recently, and they have done some adjustment. But in any event, 98.6 degrees Fahrenheit normally. 1 hour later, the body temperature cools down to 85 degrees. So of the 3 suspects, SpongeBob had an alibi until 12 a.m. Mickey Mouse had an alibi between 7 and 10 p.m. And Goblin had an alibi for 10 p.m. and after. Who has a good alibi? So CSI, forensic, this is one example that calculus is used. So first and foremost, let's see what's given and then we follow that. It's always important to write the given symbolically, everybody. So to begin with, we are at 1:30. When t equal to 0, it's 1:30 a.m. The temperature is 55. That means the surrounding temperature is 55. The body temperature, that means T sub 0, is 87. 1 hour later, that means T of 60 is 85. By the way, you have a choice of going with minutes or hours. You can write T of 1 is 85, then you have to stick with hours. Either way, you come up with the same answer as long as you're careful with your calculation. So that's what we have. So what are we looking for? What are we looking for? The normal body temperature should be 98.6. So we have to look for the time that the temperature was 98.6 degrees. So we find the time, the temperature of the time, what time? That was 98.6 degrees Fahrenheit. This is the process we are going to follow. And to follow that, we're going to go with the Newton's law of cooling. And because y sub 0 is T sub 0 minus T sub S is 87 minus 55, which is 32. So we have the formula in the following manner. T of t is 32 e to the power of kt plus 55. Everything is in order. What's missing is k. How do we find the k? We know t of 60 is 85. So if I replace the lowercase t with 60, the uppercase t must be 85. And we solve that by moving the 55 and subtracting it from 85, we get 30. We're going to divide by 32. The left side has e. We take a natural log of both sides. And when we do so, the left side becomes the exponent and exponent only, 60k. So what is k? ln of 30 over 32 divided by 60. Again, notice we know it's 15 over 16. I just want to show you where the numbers are coming from. Put it into a calculator, bunch of decimals, results in negative 0.001075. So now we go back to the formula that we had here, and we replace the k. So we say T of t, therefore, this means therefore, T of t must be 32 e to the power of negative 0.001075 t plus 55. Now we are in business. When should it be 98.6? Well, let it equal 98.6 and solve for the missing t. And move the 55. We get 43.6. Divide by 32. Because the base is e and we are solving for t, take a natural log of both sides, and the left side just becomes the exponent. Since we are solving for t, divide by the coefficient of t. Put it into a calculator, resulting in negative 287.7, about negative 288 minutes. Meaning what? T equals 0 corresponds to 1:30. T equals minus 288, that means 1:30 a.m. minus 288 minutes. And it's 8:42. What might help? 288 is close to 300 minutes, which is 5 hours. So 1:30 minus 5 hours would be 8:30 p.m. Okay. So the other 12 minutes, so 8:42. So we're going to go back and look at everybody's case. So SpongeBob had an alibi until 12 a.m. So that's fine. Mickey Mouse from 7 to 10. That's fine. Goblin had an alibi for 10 p.m. and after. 10 p.m. and after. So Goblin does not have a good alibi.